Well, hi everyone, and welcome to the latest in our series of webinars about the future of edge cloud and edge computing. I'm Dave Comrie. I'm the head of product architecture at Cox Edge, and with me is Raj Nair. Raj is the CEO of Avesha, and we're going to talk about Edge Fabric today and what that makes possible. Hi, Raj. Welcome.
Hi, Dave. Hi, thank you. I look forward to this.
Great to have you here. Yeah. So here at Cox Edge, we've been exploring new approaches and implementations of Edge Fabric. And since this series is about getting a heads up on Edge developments early, this is a great time for people to hear about it, what it is, how it's used, and what the pros and cons are. Avesha's is well down the path with federated Edge Fabric. So Raj, I appreciate you giving us some insight today into it. So if you're ready, I'll hand it over to you. And later we'll take some questions from the audience. Does that sound good?
Yeah, it sounds great. Thank you, Dave. I'm looking forward to describing about this whole concept of a federated edge fabric and see how that works and all its the key aspects of it and some cool things that it can do. So without much ado, let me go to the next slide here. So here we are talking about a smart edge fabric, and why it's smart is because it's actually something that is built for applications to be deployed on such a edge infrastructure, and where we are taking into account the connectivity, security, and performance, and most importantly, ease of use. So that's the key benefit that we're bringing. So when you talk about realizing this, latency, and what we're looking at is the low latency that you need for your application, which is the reason that an edge is important, is that you want to be deployed close to where your audience is. And so that is one of the most important aspects of it. At the same time, because you have the edge and it has, it is a distributed infrastructure. So you want to be efficient as possible in that deployment so that you can make use of it, and it can be shared among different applications effectively. And so the connectivity part of it and security is that you're talking about a situation where you have multiple clusters at different locations, and you want to automate the way in which these are connected so that you don't need to, as a user, worry about that. You can think of it as a connected fabric that is very secure and that you can feel free to deploy your applications into. And from a performance standpoint, we would make sure that it is performing at the level that you want and giving you the latency that you need, and it's constantly monitored. So this is one of the key aspects of it. As far
So
as the,
Raj,
yeah,
on the latency topic, and I know a little bit about your technology and kind of the application slice that you put kind of across these locations. What how does having that application slice play into latency concerns? How does it help you manage latency, reduce latency through that application slice concept? Maybe you want to talk about that just a little.
yeah, great question, Dave. So why do we call it an application slice? Because every application, their latency needs are different, and in fact, even there may be different trade-offs. Like they want certain applications have very low tolerance for latency, and on the others, that's not so big a deal. So you need something where you can actually specify that and then have the fabric adjust to the needs of the application. And also in the case of the edge fabric, for example, if you have a user that's coming in from a particular location, you want his service to be deployed at an edge that's closest to that user, and while maintaining the cost, and also having the performance that application needs. And if you had multiple applications, then for example, you would need to have some priority between them. So these are things that the edge fabric automatically does for you. So you as the user can just feel free to just deploy and specify what SLA you want, and the fabric will just make sure that that happens, through the life cycle of that application. Now, that's the most important aspect of what an application slice can do.
Thanks, Raj.
And then, just wanted to point out that, from a ease of use, what we're trying to do is make this a full self-service kind of a user interface where a user can just go in and, create the slice that you want and deploy your application on top of it. That's simple. It's completely driven by a graphical user interface, and so it's very, very easy to use. So with that,
Excellent.
Yeah. Any other questions, Steve?
No, that's great. Let's keep forging ahead.
Yeah. So one of the important aspects of this Edge Fabric is this thing called workload placement. And what that means is that depending on where you are, where the end user is, you want to make sure that the workload are deployed in such a way that you can meet the SLA while at the same time not overloading one edge over the other. So that intelligence is what is built into this Edge Fabric, and it all begins with, for example, where your DNS is going to resolve you to. So and that needs to be done correctly. And the way we do it for this Edge Fabric is that we are constantly looking at the latencies and then making sure that the user is sent to the appropriate edge. And then if for example, there's a lot of users coming from that location, then you want to scale up the pods in that location, again, in a proactive way, so that you continue to provide the service while at the same time not do it in a way that will be wasteful of resources or not meet the SLA. So this is where the intelligence comes in, and we use AI with reinforcement learning to achieve these goals. So let me, Cox Edge is a very interesting topology. I'll have Dave describe that. He's most closest to that.
Yeah, no, thanks, Raj. And like your points about how you route traffic and where you route traffic, to put a real fine point on it, when you move from public cloud sort of scenarios to an edge scenario, you're introducing a lot more locations and points of presence. So kind of the diagram here is depicting, a typical cloud scenario. So the little clouds here, the US East and US West, that's very typical, right? You might have something, stood up in the East Coast and something stood up on the West Coast for some resiliency and some locality. But that's managing two locations. Once you introduce the edge, your locations are going to multiply. So now, close to those those cloud connections, you're going to have more and more sort of satellite sites and edge sites introduced to the network. And once you do that, now you need a more intelligent, sort of automated way to think about how do I manage my resources at each of these edge locations. So on this diagram, the C sort of represents the service or the microservice that might be working as part of an application. And you can see that that microservice may have a presence on the public cloud, but it may also be present in the edge. And that's part of the application slice technology, because it's going to extend that microservice domain, if you will, to the edge locations and make it simple for things running in the cloud to be able to talk with things running at the edge. This simplifies migration, it simplifies the load balancing. It really, for a developer, I don't have to go rewrite my applications to use Edge. I can extend the microservice architecture that I already have out to the edge using this application slice technology. I don't have to change IP addresses. I don't have to manage all this kind of stuff that typically you think about when moving applications outside. And then each of these sort of little clicks there represent end users who are interacting with an application. That end user wants to connect to wants to connect to a service or get some data out of the cloud to power an application that's running on that phone or that laptop, where do they get that from? And most of the time, they're going to get routed to the nearest geographical location. But to your point, Raj, um, maybe you can describe some scenarios like when you're out of resources at that edge, and or the edge doesn't have the capability that you need. That's when you need more workload orchestration. So how does your edge fabric solution sort of solve for that and
Yeah,
anticipate?
absolutely. Exactly. So that's a very good point, Dave. And what happens is, when you run out of resources, you need to have a way to uh, have that service, be located or maybe expanded to another location, and you want to spin up that all automatically without any human being having to do this, and that is where the this load balancing that we're talking about comes into play, because what it does is it'll actually go to another location and then spin it up there, and again, a predictive way bring up workloads, pods, and then this would cater to that location, and I mean that new place where it has spun up, but it makes sure that the latency, the end-to-end latency seen by the user is still maintained. And so that is a key aspect of it. And it's a learning algorithm, so it's actually continuously improving. And we have some examples of, for example, we
But
compare.
before you go to that one,
Yeah,
Raj, I wanted to ask you
yeah,
as well about the security of this, because
yeah.
one of the things when you start moving from this cloud to that cloud to this edge to that edge, now my data is getting in more places. I got to worry about
Yeah.
security. Each one of these spots or pins on the map, if you will, could represent, let's say, a Kubernetes cluster, and those are typically independently managed. And that's one of the things I love about Edge Fabric is I don't have to think about, um, or it allows me to connect multiple of these Kubernetes clusters together as if I were in just one big Uber cluster, which is
Yeah.
great. But when I do that, now I'm crossing some security domains. So uh, at a granular level in terms of security, isolation, customers typically look at namespaces for this, but that doesn't quite fully cover the picture. So how does Edge Fabric help with security?
Oh, absolutely. Because what we're doing is there's automation for this that actually would connect all these locations through a mesh of VPN tunnels. And when it does that, and it is all automated, so you don't need to worry about rotating certificates and so on. Everything is done for you. But this through this mesh, and there's a central controller that allows you to not only uh, discover services that are at different locations, but also to coordinate the whole thing so that all your policies, so whether it applies to resources at different locations or access controls, they are maintained. So you don't need to manually go and ensure that it is the same access controls at different locations. It is done for you. So the beauty of that is, and it's all using namespaces, but it's making sure that the namespaces are managed. So it's called the namespace sameness. It's actually the maintained in each place with the same relationships that you have. So that if you have a particular department under a certain for a company, and its relationship with other departments and with the company is maintained at all locations. So the beauty of that is that you, as the administrator of this, it's one console, and from where you can easily manage this infrastructure, and you don't need to worry that there are holes, there's some manual error done somewhere, because it's not. It's all automated, and so that's the beauty of this. And everybody knows that human beings are the weakest link in security. So you want to make sure that you need as little human interaction as possible to maintain the security of a distributed infrastructure like this.
Awesome. Yeah, some folks may look at this and think about service mesh also. And so how does this either work with service mesh or not work with service mesh how do you kind of address that, that question we hear about service meshes?
Yeah, so service meshes are, we can work alongside them, but their main role is, within a cluster, and this is where they're good for the communications of the containers inside of a cluster. But once you go outside, a lot of the work you have to do is all manual. And this is where we come in play and we automate that. So sure, we can work with a service mesh if you have one, but again, our goal is to, in this infrastructure, is to think about what happens if you are in multiple clusters and how do you manage all of those services that are spread out, and that's where we come in.
Awesome.
So
Now, I think you have some slides here about the auto scaling. You started mentioning the workload placement.
absolutely. So this is a result from our recent work that we have where we looked at the way we do auto scaling versus what you get from a hyperscaler, let's say the most popular one. And what we found was that the way, because there is not too many controls that they offer, and so it is a sort of static type of control. So once you set it up, then there is no proactivity. There's nothing like SLA based for applications, and there's no learnings or anything like this. So what you get is in this graph, what you're seeing is this blue line. That is actually the load that is coming, and in many cases the loads are periodic, so they go up and down. And then you want the number of pods, which is the orange line here, to scale up and down. And sure, it does, but it is not that proactive. So wherever the load goes up, you will see a lot of losses, and that's what these red bars, these are indicative of the where the SLAs are not being met, and you're getting errors. And you can see that it's quite a few, right? On the other hand, if you now turn on the Avesha's reinforcement learning based auto scaling, you can see that the errors have essentially gone, have disappeared. And this is because we are proactively spinning up these pods, and well, at the same time, we are not like wasteful of resources. It is just enough. So that is the beauty of using a reinforcement learning model. It's like you have a little person there who's monitoring this and constantly turning things up and down. And it's just that it's not a person, but it's a little machine. So that's the beauty of it. And you can save up to like what we have seen is like 20% of cost. If you were to mimic this kind of performance by using some static controls, it would cost you 20% more. So
Yeah, and this was a real light bulb moment for me, Raj, when looking at the technology that you have, those SLA violations. Not only are you fixing them, but you're also allowing the customer to reduce cost.
Yes.
So you're improving the quality and reducing the cost. Usually those things don't come hand in hand. And part of that is because, in that previous graph, you'd have to like over commit or over allocate resources to make sure you stayed one step ahead of those errors. And that's wasteful, right? Versus having something predictive. You're deploying just what you need and you're going to need, and it's solving that cost problem, but it's solving the quality of experience. It's really, really cool.
Yeah, and I just wanted to add that the SLA itself, it can be anything. So we used the failed request, but you can use latency. You can use any particular metric you want. All you have to do is train the model, and the model is trained over the period of time. Like in this case, if it was, let's say, if it was over let's say these variations you're seeing is over a period of a day, then you just train the model for 1 day, and then it then learns, and that's the beauty of it. So you can literally have models that are trained for your applications, and then you deploy them, and then you can get this kind of performance. And this is really exciting, to bring this to the market.
Yep.
And Yeah, and then here, what we are showing you is the UI that you will see. You can actually see in real time all the performance of different slices, different that you've deployed, and all the benefits of this load balancing and the AI-based HPA and so on. And then at the same time, one point I just wanted to talk about is that if you were, let's say, having VM-based workloads, you can actually, we have a technology called VM Cube where you can actually take that VM and put it in a container using this project called KubeVirt. It then just deployed alongside your other container workloads, and it can enjoy the benefits of these Kubernetes orchestration, and you get all the benefits that we just discussed.
Yeah, and this is super nice from an operational perspective. It's a little small on the screen, but really between every location, every cluster, every microservice, we're able to drill down and look at the latency, and not just the latency like now, but also historical latency metrics. So you really get a full picture of your edge application. Um, Previously you didn't really need all of these, like this level of detail, if you're just deploying to a couple sites of public cloud. But with edge and moving to tens or hundreds or thousands of locations, you're really going to need that handle on the latencies that are happening between your different, just troubleshooting and trying to figure out, where is my application slow, where do I need to tweak some things. Like, this is all built in. You have that visibility, you have that microservice to microservice visibility and ability to control and prioritize that traffic too. So it's really powerful, both from a offering perspective, but also kind of in your day one, day two ops as well. It comes in super handy.
Yeah, that's a great point. So with that, I'll move to this and.
Yeah, so we wanted to leave a few minutes for questions that are coming in from the audience. So please, we have a couple in our chat here. We'll go through those, but if there's any additionals, please throw those in there. In the meantime, I just wanted to set a couple reminders for the audience. The QR code on here, it's going to take you to our website, coxedge.com. You can sign up for free trials, see our latest offers. You'll also see a link to Avesha's website here if you want to learn more about what Raj was talking about today. Secondly, when our session ends today, you'll see a website with links to more resources and options that you can click in to learn more. Okay, so going to the chat, a couple of questions came in. So our first one, Raj, this is about VPN. Do you have to set up VPN at all of the locations, or how does that part work?
Yeah, I mean, that's the beauty of this automation that we are bringing, because yes, you do need VPNs, but you, the customer, doesn't need to worry about that. This is automatically done for you. The VPNs are created between pairs of sites, and it's all completely automated. And yes, you don't need to worry at all about setting these up or even think about them, because it's even managed automatically, the certificate rotation and all of that. So it's just a completely seamless experience from a user standpoint.
Excellent, thanks. And one more question. How does Edge Fabric work with load balancers? Can I use my existing load balancers, or does this replace those?
Now, you could use your existing load balancers. This will work in conjunction with it, because we are not, this load balancing that we are talking about is actually done at a global level. And it's, so the ones that you might be using are more cluster specific. And in that case, you can obviously continue to use them, and it'll work quite well alongside both those load balancers.
Awesome, cool. if we haven't gotten to your question today, apologize. We're out of time for today. But I wanted to again thank Raj for joining us and telling us about Avesha and about Edge Fabric and all the technology that he's developing. And look forward to seeing everyone on the Cox Edge soon and getting to play around with some of the stuff. So thanks, everyone.
Yeah, thank you.